Okay, so today we're going to focus on distinguishing between strong and weak acids and strong and weak bases. What are they, and what happens when they react with each other? So what is the difference between a strong acid and a weak acid? A strong acid has a 100% divorce rate. That means 100% of them will give away the hydrogen ion. A weak acid, only about 5% are bold enough to give up the hydrogen ion, if forced to. Playing the part of the hydrogen ion today will be this bottle. This bottle is a hydrogen ion. Okay? So if I'm a strong acid, I hate this bottle. I want to give this bottle away. I will find the nearest person and give it away because I hate this bottle. I want to get rid of this bottle. And there is no compromise. I must give away this bottle. Serenity! There's the bottle. Thank you very much. Goodbye.
That was terrifying.
Okay? I'm done. I'm done with the bottle. I'm done with the bottle. It's kind of like these guys that once the girlfriend cheats on them or the girlfriend miffs them one more time, that's it. They're done. And they never go back. They never go back. It's like, done. Done. Julie, done. Don't hate you, but we're done. Never, ever again.
Are you venting right now?
No, I'm playing the part of a strong acid.
Oh.
Now, if you're a weak acid, this is what you do. You're going around going, oh, it's such a nice bottle. Such a nice bottle. I don't know, should I give it away?
Give me your bottle.
I don't know. Okay, maybe. No, I have to get it back. I have to get it back. But you seem like the kind of person that would take care of this bottle. This would be a nice bottle for you here. You can have it. No, I can't give it up. I'm sorry. This is my bottle. I love it. It has a yellow cap on it. It's a great bottle. Okay, fine. You take it. No. That's a weak acid. Kind of like a guy that just, the girl cheats on him and he gets mad and he goes, okay, I'll take you back. I didn't like what you did, but I'll take you back. And then she cheats on him again and he says, oh, you cheated on me. You're not a nice person. But I'll take you back. I'll love you anyway. That's a weak acid. A weak acid. Some examples. Look at this. HCl. Bam. Done. Divorce. Done. Notice the arrow goes only in one way. While vinegar. Oh, okay, I'll give up the bottle. No. I'll take it back up. No. I'll give it up. No. I'll take it back up. No. I'll break up with her. No. I'll take her back. She's nice and she's pretty. But I'm going to break up with her the next time she cheats on me. Vinegar. Aren't you glad? That's why you can consume vinegar. Because it is the hydrogen ion that will hurt you. Not the Cl minus. It is the hydrogen ion that will hurt you. In this case. Some of the negative ions can hurt you too. But it's the hydrogen ion that will hurt you. So when that hydrogen ion is absorbed by the water, and remember, you are 70% water. So when that hydrogen ion is absorbed by the water, it completely changes water. It changes you. It hurts you. So vinegar doesn't hurt you, even though there's enough hydrogens let loose in vinegar for you to taste the sour taste. Vinegar does not hurt you enough to damage your throat as it's going down. Now, you do realize you have hydrochloric acid in your stomach, right? Yeah. I mean, when you get really, really sick, has anyone ever been really, really sick? I mean, there's nothing in your stomach anymore. There's no food in your stomach, but you still get sick. Yeah. Okay, when you are so sick, there's nothing in your stomach, and you get sick, and it comes out kind of a bluish green liquid, that is gastric juices. That is hydrochloric acid.
What?
Yes. When there is nothing left, and you still vomit, you could possibly vomit. Believe me, from personal experience, not with me. My wife one time got a stomach bug, and she got so sick that, yeah,
It was blue?
bluish green. Yep.
Oh, man.
Yep. Nasty. Yes.
Whenever you hang upside down, like after you eat, what keeps everything from like going out?
You've got a sphincter. You've got a door at the top of your stomach that prevents
only
it.
goes down.
No, it can come back up, but it has
But
a
not
muscle.
unless
There's a
you're sick.
muscle.
Yeah.
Yeah, there's a muscle there that will keep it down. Vinegar, citric acid, so Sour Patch Kids,
Oh, I hate those.
sour balls, anything that tastes sour, orange juice, that's citric acid.
Lemons.
Aspirin is acetylsalicylic acid. Lemon is citric acid. Anything that tastes sour, and there's tons of stuff. Ascorbic acid, vitamin C, anything that tastes sour is something that is wishy-washy, that doesn't want to give away the bottle most of the time.
What about spicy?
Spicy is something different.
I had Taco Bell last night.
What about strong bases? Strong bases, as we saw yesterday, you can think of a strong base as something that gives hydroxide or something that takes hydrogen. Either way will work. But if it's a strong base, it always wants to do it. Always. Always wants to do it. If it's a weak base, I don't know. Should I take her back? She cheated on me. I don't know. Okay, maybe. But just this one time, she cheats on me again, that's it. I'm going to become strong. No. No. JK is the key acronyms for a weak acid or base. Because they're always willing to go back to the way things were. Just kidding.
So they're liars.
I still love you. No, they're just weak-willed. Weak-willed.
They're like playing.
Here's some examples. Notice the arrow. Sodium hydroxide, done. Gave off that hydroxide, done. Done. Oh, but baby, I still love you. Don't care. But baby, I still care. Don't care. Done.
That's good.
While ammonia, will I take the hydrogen? Sure, come on, baby. We can become ammonium again. I don't know. I'll give the hydrogen back. I can't take her anymore. She's always cheating on me. And then it's like, no, we can go back. No, we're breaking up. No, let's come back together. No, we're breaking up. No, let's go back together. No, we're breaking up. That is a weak base. You guys don't know anybody you're not like this, right? You're a strong acid or base, right? You don't know anybody that keeps going back. No, okay. All right. Serenity. I think you can do this. You can help me out. We're going to demonstrate this. We're going to dramatize it for them.
Bases are not all created equal. Certain acids really like to get rid of their protons and will only reluctantly convert back from their conjugate base by accepting the proton. We call them strong acids, and the conjugate base is a weak base. The same can be said for strong bases and their weak conjugate acids. The reason why all of the most interesting acid-base chemistry happens in water is that dihydrogen oxide is really great at being either a base accepting a proton from an acid or an acid donating a proton to a base. Thus, water is the world's most common acid and also the most common base. So, What does any of this have to do with power plants in John Mullen's face? When coal is burned, the sulfur in it reacts with oxygen to form sulfur dioxide. That sulfur dioxide then reacts with water and oxygen in the air to form sulfuric acid. When that sulfuric acid rains down, a set of acid-base reactions take place that damages limestone and metal and acidifies the water supply, making life harder for fish, coral, salamanders, and pretty much everything else. Limestone is mostly made of a chemical called calcium carbonate. The carbonate acts as the base, accepting sulfuric acid's protons and converting into carbonic acid, the conjugate acid, which breaks down into CO2 and water. Calcium and sulfate ions may precipitate as a salt that's more commonly known as gypsum. Okay, so the average ton of coal burned in America is about 3% sulfur. Supposing 100% of those 30 kilograms of sulfur leaves the smokestack and converts to sulfuric acid, how much limestone could that completely wash away?
Okay. There are three types of acid-base reactions. What are they? Strong acid with strong base really forms nothing. It forms water and a salt, and that's it. It's not reversible. Strong acid. Oh no, maybe I should take the hydrogen, maybe not. Weak base forms a situation where it goes back and forth. Weak acid, strong base forms an incomplete neutralization, goes back and forth.
There's no weak acid, weak base.
No, and Alex and Serenity and I will be able to explain to you why that's not the case. All right, Serenity, can you come and indulge in thespianism with me? You know what a thespian is?
I used to.
An actor.
That's a-
An actor. Since Emmy's not here, you're my next choice. I think you need to be in Master Switch. I think you can do it. Okay, so you're going to play the part of a base. Your job is to take the bottle. The bottle is representative of hydrogen ion. Okay? I'm an acid. I have the bottle. I could give it, okay? If I give it, I'm acting like an acid. If I'm taking it, I'm acting like a base. So, let's just simulate this. So when I'm an acid and I give the hydrogen, what am I? I'm an acid, she is a base. Now she has the bottle, so what has she become?
An acid.
An acid. So if she gives it to me, what do I become?
An acid.
An acid, and I can give it back to her. Whoever has the bottle is the acid. Okay? Whoever takes the bottle is the base. So I don't have a bottle, I'm a base now. She gives it to me, I have the bottle, I'm an acid. So acids and bases do those kinds of things. They're giving the hydrogen away. If I'm a strong acid, I desperately want to get rid of this bottle. I hate this bottle! I want to get rid of it. If she's a strong base, she wants to take it. She wants it really, really bad. Okay? Now, whatever you are before the reaction, you become the complete opposite after. So if I'm a weak acid, I'm a wishy-washy person. So I go like, I like this bottle. If you want it, you can have it. Never mind, I like it too much. I can't bear to be without it. But if you want it, you can. No, I don't like this bottle. I like the yellow cap, and it's a beautiful bottle, and there's all sorts of stuff, and there's something in the middle, which I don't know what it is, but it is wonderful. But maybe you can have it. No, I changed my mind. I want it back. That is a weak acid. That is a weak acid. If you're a weak base, you're doing something like this. Oh, I see you have a bottle there. I'll take it if you absolutely want me to, but I would prefer not to. Do I have to take it? Fine. That's a weak base. Okay? So the first one we're going to dramatize for you I'm a strong acid, and you are a strong base. So I become a weak, I was strong acid, now I become a weak base, and you become a, no, you were a strong base, now you'll become a, okay. So let's see why this reaction is not reversible. I hate this bottle! Take it! If you want, I can take the bottle back. If you don't want to give it up, then that's fine. Alright, that's it. Done. Done. Usually what results is a strong base has a hydroxide. When she takes the hydrogen, the hydroxide and the hydrogen combine together to form water. And then what's left over forms what we call a salt. Not the salt. When we think of salt, it's NaCl. But whenever a strong acid and a strong base react, it forms a salt. Anything that forms, anything that's discarded after a strong base and strong acid reacts is a salt. Okay? So, I am now going to play the part of a strong acid, and she's a weak base. Ready? Now think about it. You got it? You think you have it? But once you get it, what do you want to do with it? What do you become? No, you are a weak base, so you become strong acid. And I'm a strong acid, so I become... I hate this thing! Take it! You're strong acid now.
Take the bottle.
No!
Take the bottle.
No, you're putting pressure on me!
Okay, take the bottle.
Okay, fine. I hate this bottle! You take it!
No, you take it.
No, you take
I
it!
don't want the bottle.
You take it! I don't want the bottle either!
Take the bottle.
I don't want the bottle!
Ah.
Ah! So, when will this reaction end?
Never.
We keep passing the bottle along. Okay? So, this always results in a conjugate acid-base pair. What we become after the reaction is called the conjugate. Conjugate. Okay? Now, I'm playing the part of a weak acid. She's going to play the part of a strong base. Think you got it? Yes. I like this bottle. It's a beautiful bottle. You're a strong base. It's a beautiful bottle. What do strong bases want to do? No.
They
opposite.
do.
They want the bottle bad.
Give me the bottle.
No!
Give me the bottle.
No!
Give me the bottle.
No!
Give me the bottle.
No! No! Ah! You took my bottle! Give it back! Oh, it's a beautiful bottle.
Give me the bottle.
No!
Give me the bottle.
Just take it. No! Ah! You took my bottle! I'll give it back. Oh, I like this bottle.
No, give me the bottle.
No! Don't take it! Oh, she took it away from me again. Give me that bottle. Okay, so it goes on and on and on. Last possibility that I didn't list here. You tell me why I didn't list it here. I am now a weak acid. She is a weak base.
Because no one
Nothing
wants
would
it.
happen.
I like this bottle. If you want, you can have it. But okay.
Nothing happens.
Okay.
Okay, so nothing happens. Thank you. Sit down. Great job. Serenity, I really, 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 truthfully think that you need to try out for Masters next year. All right, so what happens when a weak acid reacts with a weak base? Nothing happens. You have two weak-willed person going, what do you want to date? I don't know. Do you want to date? I don't know. Do you want to date? I don't know. What was it? Was it in Dumbo that he had those crows? What do you want to do? I don't know. What do you want to do? I don't know. What do you... What was it? The Jungle Book. I don't know. What do you want to do? I don't know. What do you want to do? I don't know. What do you want to do?
SpongeBob and Patrick.
Okay. So basically, when you have a weak acid and a weak base, it's, I don't know. What do you want to do? I don't know. What do you want to do? I don't know. What do you want to do? What do we call a reversible reaction? A system that is in equilibrium. A system that is in equilibrium.
But as with most things in chemistry and in life, when it comes right down to trying to define exactly what something is, it gets weird and messy and confusing and terrible. So, forget everything you ever learned about acids. Wipe the slate clean. The most common acid on Earth is water. And water is also the most common base. And am I saying this purely to confuse you? Yes! Well, mostly to convince you that the world is way more complicated than you thought it was.
Water is essentially a weak acid and a weak base at the same time. So how that plays out, I'll show you tomorrow.